Now, important part, types of hypothesis. Some would stand by the notion that there are only two hypotheses of types of hypothesis, a null and alternative. While that may have some truth to it, it would be better to fully distinguish the most common forms, as these terms come up so often, which might leave you out of context. Apart from null and alternative, there are complex, simple, directional, and non directional, statistic and associative, and casual hypotheses. They don't necessarily have to be exclusive, as one hypothesis can tick many boxes. But knowing the distinction between them will make it easier for you to construct your own hypothesis and do a best research work. So we'll start with first null hypothesis. A null hypothesis proposes no relation between two variables, denoted by HO. It is a negative statement like attending physiotherapy session does not affect athletes on field performance. Here, the author claims physiotherapy sessions have no effect on on-field performance. Even if there is, it is only a coincidence. Next is alternative hypothesis. So consider to be the opposite of null hypothesis. An alternative is donate as H1 or HA. It explicitly states that the dependent variable affects the independent variable. So a good alternative hypothesis example is attending physiotherapy session improves athletes on field performance, or water evaporates at 100 degrees Celsius. So the alternative hypothesis further branches into directional and non-directional. Directional hypothesis, a hypothesis that states the result would be either positive or negative, is called directional hypothesis. It accompanies H1 with either or sign. So non-directional hypothesis. A non-directional hypothesis only claims an effect on dependent variable. It does not clarify whether the result would be positive or negative. Simple hypothesis next. A simple hypothesis is a statement made to reflection the relation between exactly two variables, one independent and one dependent. Consider the example here. Smoking is prominent cause of lung cancer. So the dependent variable, lung cancer, is dependent on the independent variable, that is smoking. Complex hypothesis. So in contrast to the simple hypothesis here, a complex hypothesis implies the relationship between multiple independent and dependent variables. For instance, we'll take an example. Individuals who eat more fruits tend to have higher immunity, lesser cholesterol, and high metabolism. Independent variable is eating more fruits, while the dependent variables are higher immunity, lesser cholesterol, and high metabolism. This is how you differentiate between independent and dependent in the complex hypothesis. Associative and casual hypothesis. So this hypothesis does not exhibit how many variables there will be. They define the relationship between the variable. In an associative hypothesis, changing any one variable, dependent or independent, affects others. So in a casual hypothesis, the independent variable directly affects the dependent variable. Last is empirical hypothesis, also referred to as working hypothesis. So here, an empirical hypothesis claim a theory's validation via experiments and observation. This way, the statement appears justifiable and different from a wild guess. Say, the hypothesis is women who take iron tablets face a lesser risk of anemia, those who take vitamin B12. So this is an example of empirical hypothesis where the researcher statement after assessing a group of women who take iron tablets and charting the findings of it. Then is statistical hypothesis. So the point of statistical hypothesis is to test an already existing hypothesis by studying a population sample. So for example, hypothesis like 44% of Indian population belongs in the age group of 22 to 27, leveraging the evidence to prove or disprove a particular statement.